In this video, I'm going to talk about how to measure the price elasticity of demand. In the previous video, we talked a little bit about what price elasticity of demand is and what some of the meaning of the ratios that one ends up with in doing a measure of elasticity for some good in particular. But I wanted to sort of go through some of the math because it does seem to be one of the more challenging aspects that students find in introductory microeconomics. And I want to sort of walk you upward here toward what is the standard formula and the most accurate formulation of the price elasticity of demand. Before I do that, I want to sort of work with a little bit simpler kind of model, which hopefully is intended to sort of break down for you some of the logic and the thinking of how we get to this measurement. Because up to this point, what I've really only given you is that we're talking about the percentage change in the quantity demanded of a good, whatever the good in question is, divided by the percentage change in the price of that good. This doesn't really get you to a workable formula, does it? Because when you're talking about the percentage change in something, what does that really mean? And how do we get to that? Well, it's very simple. If we talk about the percentage change in the price of a good, we're simply talking about the change in that good over that original good, and we'll call that the original condition of that good, which we'll call Q1, and the percentage change in the price of that good is simply this particular formula, delta P over the original P, keeping the absolute value expression intact. And then what is delta anything, whether it's this course or mathematics or wherever? It's simply new minus old, that is Q2 being the new value, Q1 being the old value, divided by the original Q1. And then under the other grand fraction here, it's the same with delta P, P2 minus P1 all over P1. And that is a formula that is useful. And it may not be the most accurate, but it's one that's the most simple to work with. It may not look simple, but it's the easiest one to work with. This is a formula that we simply refer to as the point method, or more formally, the point price method. And I'll do a couple of examples here in order to show how we arrive at these particular kind of measures of elasticity and what it means and how we can interpret these. So let me do a couple of examples here, and using the same data points, and I'm going to be making a couple of assumptions with regard to what's happening to price, either price going up or price going down. And we're going to keep the same demand curve and the same functional relationships in terms of the proportions between the changes in price and the changes in quantity. And then we're going to see what we end up with in terms of different sorts of elasticity measures. And so, in general, let's just draw a PQ plane here and draw a demand curve like so. And right now, we're not really interested so much in the configuration of it, in other words, what the slope of it is. But let's say that we've got in this scenario, we're going to say that we've got a change in the price that is upward. So we have an upward change in price. And so let's start with some initial P1, Q1 combination. P1 in this case is equal to $8, and Q1 is equivalent to 15 units. And again, the price is going up now, so the price is going from P1 to P2. We're saying that the new price for this good is $10, and we would expect the quantity to fall, and it does, and it falls to 10 units. And so the question is, what is the price elasticity of demand for this particular relationship, given price of the good going up, quantity demand of the good falling? So let's do the math on this and see what we end up with. So we're going to start with this point price method, Q2 minus Q1 over Q1 divided by P2 minus P1 over P1, absolute value of the expression. And all we're really doing now, the math should be relatively straightforward, is we're plugging values in. So Q2 minus Q1 is 10 minus 15 over 15. That's Q2 minus Q1 over Q1 divided by P2 minus P1, which is 10 minus 8, all over P1, which is 8, absolute value of that expression there. And to solve for this then, again, the math is relatively straightforward. You get negative 5 over 15 divided by 10 minus 8 is 2 over 8. And so what is it that we end up with here? Well, we know there's a negative, we have a negative fraction divided by a positive fraction, and we know that we're taking the absolute value of this. And so if we know that, let's just get rid of the negative sign there, and now the absolute value relationship is not relevant. And you can solve this however you like. You can keep it as fractions, or I think I sort of have a preference taking fractions and converting them to decimals. I think it's a good practice to get into because pretty much everywhere in economics and finance we deal a lot with decimals, and it also, by the way, better matches the input and output that we see on a routine basis with computers and calculators. But nonetheless, you don't have to do that. If you want to do that, however, feel free to do that. I'm going to go ahead and do it here. 5 over 15 is 1/3, or 0.33, divided by 2 over 8, which is 0.25. So the math is relatively simple, or you could take 5 over 15 and make it into a multiplication problem by flipping the denominator, make it 5 over 15 times 8 over 2, which is going to give you the same ratio in the end, and the value we're going to get is 1.32. And that is the price elasticity of demand for this particular demand curve as we move from this particular segment along the demand curve, the interval between 8 and 10 on the price axis and 15 and 10 on the quantity axis. And so since it's greater than 1, one thing we can say is, well, that demand is price elastic. It's greater than 1, so we know it's price elastic. So this is where we should not be looking at the slope of the demand curve and thinking that elasticity is the same as slope. Because if we were to think that, then what we would end up with is between any two intervals along the demand curve, we would see the very same elasticity measure. But that's not really how it works, unfortunately, particularly using this particular method. So let me do this. Let me reverse the condition here. And let's say that now the price is not going down. I'm sorry, the price is not going up, the price is going down. And then let's see what we end up with for price elasticity measure. So recreating the same facts, in other words, the same responsiveness of quantity demanded to the percentage change in price, let's see what happens when now the price goes down, and do we have some other kind of relationship at work. And so drawing a generic demand curve, and now we'll start with opposite conditions, where now the P1 we're starting out with is $8, I'm sorry, $10. So we're just starting from a different position. And the P1, Q1 combination is reflecting this point here. Q1 then is 10 units. And we're saying the price of a good in this scenario is falling from P1 to P2, and it's back to the original condition. All we're doing is simply reversing the ordered pairs in the direction of the movement. Price is going down, quantity demanded should go up, and we have the same relationship, the same sort of responsiveness. The price goes down, the quantity demanded goes up. Okay, so we want to take these facts for the same demand curve and the same two ordered pairs, and we're going to see what kind of elasticity measure we get. So let's do the math here. Again, the math is relatively straightforward. Q2 minus Q1 is 15 minus 10 all over 10. Now notice that we've got a different P1, Q1 combination. So in this point here, or this value here and this value here, we're going to have different values. That could mean something. P2 minus P1 is 8 minus 10 all over the original value of 10 and the absolute value of that expression. Okay, again, the math is relatively straightforward. 15 minus 10 is 5 over 10 divided by 8 minus 10 is negative 2 over 10. And again, because we're taking the absolute value, we know we've got a positive value divided by a negative value. It's going to give us a negative value. We know that. Let's just get rid of it so we don't have to worry about that expression. And then the 10s cancel, and we get 5 over 2, or 2.50 as an elasticity measure. So let's take these facts that we know here and compare this case here of the price going down and implicit in that quantity demanded going up, and compare the two ratios. In the first scenario, where we were starting out from a P1, Q1 combination of P1 equals 8 and Q1 equals 15, we had an elasticity measure of 1.32. Reversing the situation, we have 2.50. They're both indicative of price elastic demand, but they're pretty different. They give pretty different results. The magnitude of the second scenario is almost double that of the first scenario, and so that's problematic. Which is why the formula I've given you is not the one that's in the book, but it's one that's useful particularly for real quick and dirty calculations. I've seen economists use this formula just to get a sort of a general feel for what elasticity might look like. But in reality, there's a better way of doing this, and it's one that cures the problem of differing starting points. So the point price method has got a shortcoming in that particular regard. So what is the way to get around this? In fact, this is what's discussed in your text. It's the one that is asked about, in terms of the examples, if you like to work the questions at the end of the text. There's got to be a way to fix this problem, and the way to do it is this. It's to not rely upon the original starting point, but instead to do what? To take the middle value along this line here. So, in other words, we're taking the average value of that segment, Q1 plus Q2, quantity divided by 2. Quantity divided by 2. In other words, rather than starting at some Q1, which may be a higher or lesser value, and maybe a great distance from the Q2, so that when we reverse the condition, we simply divide it in half. We take the middle value. Because what is an average value of anything? It's two things added up divided by 2, or any two objects. What's the average value? I can take my age plus your age together, divided by 2, and we have an average age. Okay? And the same goes down here with the price variable. P1 plus P2, quantity divided by 2. And then again, the same absolute value expression, because we're going to have a negative value if the good obeys the law of demand. And if the good does obey the law of demand, then we know that we're going to have some negative value, but we need to be able to compare it against the all-important metric of 1. And we're not going to be able to do that if we have negative values. All goods will be interpreted as being price inelastic otherwise. This particular formula is useful, and it's the one that is the most rigorous, and that's called the midpoint formula. It's called the midpoint formula. And it should allow us then to take the facts of the case that I just gave and arrive at some value that should be somewhere in the middle if we are to interpret this correctly. And so let's take Q2 minus Q1. I'll just start from the original sets of values, and let's just say Q2 minus Q1 in this case, using this new formula, is 15 minus 10. I'm sorry, 10 minus 15. 10 minus 15. And divided by the middle values of those, which is 15 plus 10 divided by 2. And then P2 minus P1, which is 10 minus 8. 10 minus 8, all over the distance between 8 plus 10, quantity divided by 2. So if we work the math here, we end up with this 10 minus 15 is negative 5. 15 plus 10 is 25, divided by 2 is 12 and a half. And then 10 minus 8 is 2. 8 plus 10 is 18 over 2, which is 9. And if we do the math here and we do it correctly, we're going to end up with some value that's going to be somewhere between these two. And I believe it comes out to be something around 1.8 something. And without doing the math and having a calculator, we're going to end up with some value around there, which is somewhere in the middle of those two values. And this is the one way that we get around the problem. We still have a price elastic demand relationship, but what we end up with is some value that's more indicative, and it doesn't make any difference whether we're going up or down in price or up and down in terms of quantity demanded. So I hope this is helpful to you, and again, as always, if you do have questions about this or any other course matter, feel free to contact me.